Good morning. Today I'm going to go through our Unit 3, Lesson 1. So an introduction to probability, where we're going to talk about probability and odds. As always, the notes, the full copy of the notes are in Google Classroom under Class Notes. I'll just go through a couple examples here. So probability is the branch of mathematics which is used to help predict the outcomes of various events. Probability tells you how likely something is going to happen. And here's the kind of equation that we use for it. The probability of an event is the number of favorable events, or whatever you're looking for, divided by the total number of events possible. So often I kind of shorten it to say probability is equal to whatever you want, whatever you're looking for, divided by the complete total possibilities that you have. And you'll see probability will work out to be a fraction or a decimal between 0 and 1. Where 0 means it's impossible, there's a 0% chance of it happening. Where 1 means that it's absolutely certain. 1 means it's a 100% chance that that event is likely to happen. So let's switch to the next page here and do a couple of examples. So for the first one, we have a bag of marbles. It contains 6 green, 9 white, 12 blue. And we want to select a marble. What is the probability of getting a white marble? Well, what we want is a white marble. So I can see that there's 9 of them. Out of the total possible marbles we could choose from, so if you add up all the marbles in the bag, 6 plus 9 plus 12, we'll see that there's a total of 27 marbles in the bag. So the probability of getting white is 9 out of a total of 27 marbles. We shouldn't leave it like that as a fraction, we should simplify it. So you can divide 9 out of top and bottom. This is your simplified fraction. You can either write probability as a fraction or you could write it as a decimal. So if I go 1 divided by 3, you'll see that's going to be 0.33333 or 0.3 repeating. You could write it that way. Or you could write probability as a percent. So once you have it as a decimal, you can times it by 100 to change it into a percent. All of those are appropriate for probability. We will likely gravitate between either decimals or fractions for our answers. We can do the same thing here. So let's look at the cards examples. From a deck of 52 cards, what's the probability of getting a red card? Well, you're going to think in your head how many red cards are in a deck. There's 26 out of a total of 52 cards. You can simplify it by dividing 26 at the top and bottom. And you can see that our probability is either 1 out of 2 as a fraction or 0.5. How about not a club? Let's go down to this one. So probability of not a club. Remember from set theory, if we have that little prime symbol there, it means not that. So you're going to count all the cards that are not clubs. There are 39 cards that are not clubs out of a total of 52 cards. Then you can simplify that by dividing 13 out of top and bottom. And you'll get 3 out of 4. Or if you change it to a decimal, you'll get 0.75. So that's basically probability. There's a bunch of different examples there that you can look at. Let's just split this now into the next page where we talk about the difference between experimental and theoretical probability. So there's 2 different things we could go with. Experimental probability is what you think. We're actually doing an experiment and calculating the probability of it. And theoretical probability is actually just figuring it out without doing an experiment, just using math. So let's look at David rolling a dice. He does an experiment and he rolls a dice a bunch of times and he records his information in this chart. How many times he rolls each of the numbers. So if I wanted to experimental probability of, let's say, him getting a 4, means what we want is a 4. He's rolled a 4 6 times. Out of a total of, if we add up all these rolls, there's a total of 20 rolls that he did. So the probability, the experimental probability, is that 6 out of those 20 rolls, he's going to get a 4, which is going to simplify to 3 out of 10, or a 0.3 as a decimal. But if I wanted to find the theoretical probability, that means I don't know this experiment exists. I'm just going to look at my outcomes. For rolling a dice, you only have 6 different options. You can get a 1, 2, 3, 4, 5, or 6. So the probability of getting a 4, you have 1 out of a total of 6 different options to get a 4. So you can see that theoretical probability, it's a little bit different than his experimental probability. Experiments aren't always exact matches, but the more that David rolled this dice, if he did this like 1,000,000 times, the closer his experimental probability should match the theoretical probability. Okay, that's basically it for probability. So now I want to compare it to odds. Odds is something we're not as familiar with probably when you're working through things. So, probability we kind of summarized before. It's what you're looking for, whatever you want, over the total possibilities that there are. Or in other words, it's a part of something over the whole amount possible. Odds is a little bit different. It's very closely related to probability, but we write it in a bit of a different way. When we do odds, we always write it as a ratio. And a quick way that I like to write it is it's whatever you're looking for, what you want, as a ratio to what you don't want, what you're not looking for. So when you're doing odds, it's actually a part of something compared to the other part of something. You don't have any totals anymore. You're just separating it into parts. So let's have a look at the next one here. So we have 4 black counters, 5 white in a bin. We're selecting one at random. So we have to read carefully. We want to state the probability. So the probability that the counter selected is black, well, there's 4 black out of a total of 9 counters. So I know there's 4 out of 9 for my probability. Probability of not black, we could do it one of 2 ways. I could actually count. There's 5 counters that are not black out of 9. Or I know if there's 4 that are black out of 9, the remaining 5 have to be not black. So I could have used my answer from above. Now let's go down to odds 4. So we've done probability just like last page, but now if I want to do odds 4, selecting a black counter, I'm going to think, what do I want? I want a black counter. There's 4 options. Compared to what I don't want. I don't want things that aren't black, so if I count those, there's 5 options that are not black. So my odds for selecting a black counter are actually 4 to 5. You should see when you add your parts together, what you want versus what you don't want, it should equal the total possible in your probability. That's how they're related. That's odds 4. If you want odds against selecting black, it's just opposite. You're going to flip-flop those around. Okay, let's try another one here. So we're going to skip the next page. You're welcome to look at that one on your own time. Let's look at the last page of the notes here. So Brandon holds all the hearts from a standard deck of 52 cards. He asks Hilda to choose a single card without looking. We want to determine the odds in favor of Hilda choosing a face card. So what we want out of those hearts is face cards. So if we think about it, Jack, Queen, King, there's 3 face cards that we want. And so out of those 13 cards, 3 are face cards. That means the other 10 are things we don't want. There's 3 cards we want, 10 cards that we don't want. So your odds are going to be 3 to 10. If you're doing odds against, it's just going to be the opposite. We're going to flip those numbers around, 10 to 3. Let's do one more. So determining odds from probability. We want to be able to switch between the two. It's a little bit tricky and you can get jumbled a little bit. So it says research shows that the probability of an expectant mother selected at random having twins is 1 out of 32. So what that tells me is out of a total of 32 expectant mothers, that means 1 is going to have twins. On the other side, so out of 32, 1 is going to have twins. That means the other 31 will not have twins. So once you have your probability, it's nice to switch it into its 2 parts and kind of interpret it a little bit. Now that I know that, what are the odds in favor of having twins? Well, 1 option is going to have twins, but the other 31 will not. And again, when you add those odds together, it equals the total in my probability. Odds against, you're just going to flip it the other way. And that is it for that one. Feel free to look at the notes for the rest of them and practice a lot between switching between odds odds and probability and odds, because that's probably the trickiest part. And have a great day.